Hello viewers, hello everyone, welcome to the fundamental physics classes. In this, today we'll try to understand how to know the properties of light. Okay, we know already few properties of light, that is reflection, refraction, diffraction, scattering and all. In this, we'll just focus today more about the scattering of light. So what is a phenomena in the because of the scattering of the light in the nature? So that and all we're going to understand in this class. Yes, children, you already know that when light falls on any surfaces, what will happen when light, imagine when light falls on any polished surfaces, what happens? It is going to reflect back. That you know that process what we call reflection of light. In case of glass lab, a refractive index is changing from medium 1 to medium 2. If light need to pass any transparent medium and translucent, that time what happen? It is reflection, and that time it will undergo refraction process will occur. So this we will understand. Because of refraction, atmospheric refraction, some of the natural phenomena what will happen, everything we discussed already. In this class, we'll try to understand among other than this property, the light will also undergo scattering. So what is this meaning of scattering is that suppose some particles are there in the air, right children? What is there in air? Air is not a uniform body like a vacuum, right? Inside the air, the colloidal particles are there. So when light falls on these particles, it will undergo reflection, refraction. Suppose it is transparent water droplet like that, and the same time it will also undergo spreading. The light going to spread out or scatter in different directions. Light will pass because the particle, whatever there, that particle, it will try to absorb the light, and it will also emit the light in different directions. So when light, imagine this particle is here, when light on this particle falls on this particle, the particle will absorb the light and particle will reflect the light. So after absorbing, this absorbed light will going to spread in different direction. That means what we call emit in different direction. So this is what we call as a scattering. See, when a light encounters a matter not only re-emits, like it will re-emitting like this. Now it falling, re-emitting, and in also in the forward direction, leading to absorption of and refractive index. But it is also re-emit light in different direction. It won't re-emit only in the single direction. After it absorbed light will going to re-emit in different direction. This is what we call as a scattering of light. I hope this is clear, children. What is scattering of light? Next thing, light scattering is everywhere. We can observe the scattering of light in everywhere. In case of the sky, in case of the starlight, in case of galaxy, everywhere we observe the light because of the scattering phenomena only. Or else see the straight ray, the ray will go in straight this side and this side dark color it will be. But even we cannot see the dark. If the light is passing like from this side and this side, we can see the light. That is because of the light rays is scattered in all the direction. Because of that only we are going to observe this phenomena of light and all. All the molecules scatter the light. Whatever the molecule, they will scatter the light. Surfaces scatter the light, and scattering causes, what it will cause? Because of scattering, the milk and the clouds to be white and water to be appears like a blue. It is basis of nearly all optical phenomena. This is only the basics of all optical phenomena. What is occurring? Why sky will be the blue color of the sky, and the orange color in case of evening and morning of the sky, and why the clouds will be only the white color. So reason of all this phenomena, this is behind the scattering of the light only. Clear, children? Yes. The scattering of the light, the first observed by the scientist Carl Tyndall. The name of the scientist who observed and who done the experiment on this colliding particular solutions on based on the thing he explained. The name Carl Tyndall. That is why we given the name of this effect as a Tyndall effect. Is an optical property of the solutions. In case of solutions, suppose in case let us take an experiment on the solutions. In a true solution, if there is a no any molecules are in case of true solutions, we cannot see scattering of the light much. But when the same light is passed through the colliding solution, containing the colliding solution, suppose we're going to add 200 grams or 400 grams of any salt to this, that time the colliding particle will come. When colliding particles are moved, that time we're going to observe the color of the light here. Why? Because it is a scattering. Light particles is scattered by this particle. Let us take one particle. It will going to scatter the light, absorb and scatter the light in all direction. Okay, different solutions will absorb different colors of the light. Okay, so I'm going to understand that all. Yeah. See, this is what Tyndall effect. In case of true solution, we cannot see any color. When we pass the same light in a colliding solutions like containing molecules, solution containing molecule that he pass, no, that time we can see the color light will be visible and change the color solution also we can observe. That is what we call Tyndall effect. When a light passes through the solution, its path becomes visible because of the scattering of light particles. It is called as a Tyndall effect. Why? Because scattering of light particle, you can able to see the path of the light in the second one. That is because of the Tyndall effect. Okay, that is what is scattering. Okay, this phenomena was studied first time by the Tyndall and illustrated the path of the beam of light is a Tyndall cone. Okay, you can observe here. The light will be going like this. Okay, Tyndall cone, it will be spreading outward as it is go to far and far. The light is going to spread. That is what we call Tyndall cone actually. Okay, you can see here this is a source of light they taken, and here they taken a lens, and they're passing. Now it is a true solution, does not containing anything. We cannot see the path of light clearly. In the first one, we cannot see the light properly. In the second, you can observe this because of the light. You can see here yellow color and this side orange and orange. No? That is because when a light is passing parallelly, it will pass through this. What happened here? They're going to spreading of light or scattering of light taking place. Clear, children? This is what the Tyndall effect. Okay, to understand this better, in your book they give an activity to how to conduct this activity. Take one source. Yeah, you can hear and so you can see. In your book given this activity. First, you're going to take a source. Okay, this is the source and a torch bulb containing white light. When it is passes through the prism, when it is passes through the convex lens, what will happen? Convex lens, when you pass light ray through a convex lens, the infinite rays will going to focus, will converge at point. Or suppose you passing through the focus, what will happen? It will try to go parallelly. Okay, this is what we are observing here. When the light rays are passing through the lens, what happen after passing? They are going parallel rays. You can observe the parallel rays are going. This parallel rays going to the colloidal solution. Okay, the colloidal solution is containing molecules inside. When the passing through the colliding solution and pass to the small slit, that light is passing through the slit, small hole to make it collimate, and pass through again lens. Again lens means the parallel rays are falling. They are all trying to converge on the screen. Okay, you can observe on the screen, the spot of light, it is orange color light. So based on the colliding solutions we taken, the color of the light, that means different particles, colliding particles absorb different kinds of colors. Okay, remaining colors it emit, that will absorb that color, remaining will emitting. That means we're going to see the orange color of the yellow color of this sun. That means in case of afternoon, you can observe this phenomenon. In case of evening sun, you can see when say this is we can taken a colliding solutions here. Okay, in this one is a true solution we taken. Here no light we cannot able to see anything. No light we can see here. But here when containing this particle, you can observe here particles are there. Because of presence of particle, the light rays, you can easily observe this light rays passing like this. No, the path of light is visible when it is passing through the colliding solution, and after passing it will be falling on the screen. See the orange color. Okay, this is what the evening and the morning sun look like. Okay, like this source we take a true solution. When it pass, it is not to show any path. See, when starting point and ending point is coming in the glass, but inside the nothing gray is there. That means in true solution we cannot see able to see the path of light because no scattering there. If particles are there, that particles will scatter. That time we're going to see the path of a light. This effect proves that Tyndall effect. To understand done this activity, what is required? Lens. lens 1 and lens 2 required. Two lenses are required. Solution containing the solutions are required. When you're going to, initially we taken pure true solution, that time no light will be visible on the screen. When you when you add some salts inside it with some molecule, that time you can able to visible. Okay, these activities are done by Tyndall to explain the Tyndall effect. Okay, clear children? What is Tyndall effect? Yeah. See, in case of nature, you can observe this Tyndall effect when means in case of you can observe this in case of nature naturally. That is in case of gas and smoke containing the particles. That time you can see the light is scattering there. So you can observe here because of smoke, how it is looking the smoke. When light rays are passing through the smoke, we can able to see because the smoke will contain a gas particles. Because of that, we are going to observe the scattering of the light in the smoke medium. And the next, in case of nature, see in a heavy dense forest you will go. In that condition, you can able to see the light rays. Okay, usually light rays are there everywhere, but we cannot see everywhere, right? Only in case of dense forest, what will happen? Moisture is present. That means a high number of water molecules are present. That is why they're going to scatter. Okay, they're going to scatter the light. We're going to observe the light rays. How nice view we can see. Light rays are coming and striking the earth. That is what we call as a Tyndall effect. Natural Tyndall effect is occurring in the nature. And the next, see, because of Tyndall effect, or because of scattering, we can see that the different color of this. In case of a noun, the color is different, and in case of a in case of evening, see, in case of evening, the light rays coming from the sun, they need to cover more distance here. Okay, because they need to cover more distance or longer path, the scattering will be more. Okay, because of more scattering, the rays are coming from this end to this end. The red will be dominating here because it have more wavelength. And here, in case of noun, because it has a short path they need to cover from here to here. Short path. In the short path means what happens? The what is the red color will have longer wavelength. It goes out. Only the blue light will going to spread, and that too we can see the almost high intensity sun. White color sun we going to see at the afternoon because of less distance. Because of this more distance, we can see only orange color and size is also little bigger and we can able to observe. So all this phenomena we observe because of scattering of light only. And see, milk and the clouds, why they will appear white color only? Because they're going to emit all the rays. If any one ray, okay, in case of clouds, see what will happen. The clouds appears white as droplet scatter all wavelengths of visible light. Okay, because it will understood why rainbow form. Rainbow is formed because of scattering of light from the water droplet. When water droplets falls on this white light falls on the water droplet, entire light is falling, reflecting back. That is why the water droplet is present in the cloud. It can be visible as like a white color. But in case of the sky, what happened? Blue is be absorbed or scattered there only red will reaches us, so that the sky will be blue to us. Okay, the white clouds will be white color because the clouds containing water droplets, that the droplets will emit all the wavelength, that scatters all the wavelength it will going to scatter. Not only one color, whatever all the 7 colors mixed up white light, that will be scattered here. Because of that, we can see the color of the clouds will be white color. And why sky is blue? Because again the same reason why sky is blue, because of sky here in the topmost layer of the atmosphere, as we go altitude density decrease at the topmost level, the blue color going to spread here. Okay, you can observe blue and almost violet or green, they're going to spread here only, and the remaining color they will reaches the earth. Okay, which are the light rays which are scattering here, that's because of particles containing atmosphere containing the so many particles. When light falls on the blue light is going to scatter there itself, and remaining wavelength will go along. So because of the scattering of the blue light in the topmost level of the atmosphere, that makes the upper layer of this atmosphere look like a blue color. That is what we call it as a sky. Okay, sky is sky. What is a blue color sky is not any boundary and not exists. It is just appearance to us. Okay, the scattering of blue light by gas molecules in the atmosphere takes place, and sunlight is made up of all the colors. So all the 7 colors is, only the blue and violet will going to spread here, remaining place will having more wavelength, so they will reaches the ground. Clear, children? And see why blue sky and the red sunset we can see. In case of sunset, red, because why children see the reason is also same. More atmosphere, it need to cover from here to here, but here distance you can see less, and here distance it need to cover more distance, because when it is traveling more distance, more amount of scattering going to taking place. That is why more amount of scattering means, you can see wavelength is the red and orange and the more wavelength. That means when it reach having more wavelength, they reach more distance. So red and orange sky we are going to observe in case of sunset. In case of now, you can see the less atmosphere, because it is light is coming slightly, so less atmosphere need to cover and less scattering, so blue and yellow sun we going to observe maximum. Okay, and molecules in the atmosphere scatter the light ray, shortest wavelength is blue and the violet, and the scatter more, that's why they will scatter more easily in the sky. I hope this is clear, children. Any doubt in this so far? Just go back and watch. Please comment. Okay, thanks for watching, children. Keep watching like this. Thanks for watching, and please subscribe my channel.